Okay, hi and welcome to the example video for division with radicals, including variables. So we're going to do a couple more examples here for you to see and explore and get ready for the work that we're going to do in class. So looking at this example here, I've got a square root. Underneath it is the fraction 144 divided by 9. And again, individually, if I divide 144 by 9, I'm not going to get anywhere. I'm going to get to a decimal, and we don't want that. So in this particular example, we're going to employ the division property, which says that I can split this radical into two radicals, one for the numerator and one for the denominator. Now I'm able to get somewhere because both 144 and 9 have perfect square terms. So, and again, dealing with the square roots here, we're going to see if we can find the perfect square of them, which shouldn't be difficult. Should be 12 squared for 144, and of course the square root of 9 would be 3 squared. Now that we've employed that, of course, we're going to use the inverse property that square roots and squares are inverses of each other, and that's going to remove our square root. And so we should then be able to move to 12 divided by 3. And you may think because you've dealt with the radical that you're done, but if you're sitting there staring at 12 divided by 3, hopefully you realize that that's going to reduce itself down to 4. All right, let's take a look at another example here. This one includes some variables here. So looking at this, again, taking 75, it is not divisible by 16t squared. Just isn't, right? T squared is not going to go into 75 at all. So let's go ahead and separate these into the two square roots that we can have for this fraction, which is going to be the square root of 75 over the square root of 16t squared. At this point, again, we're looking for perfect squared terms, and 75 doesn't have one stand out right away, but if we look at it as 25 times 3, we notice that now 25 has a perfect squared term, and we'll use that in the next step. So that's just step 1, so you can see what I'm doing. 16 already does, and I'm sure that you were aware that 4 squared does work times t squared, and t's already ready. So those are ready to be inversed and remove the radical for us. Looking at the top then, we're going to be left with 5 squared, changing that 25 over. Oops, that moved on me a little bit. Times 3. Again, all under the radical, and then I'm going to reproduce what we had in the denominator. All right, at this point, we're going to go ahead and start to use the inverse properties here and remove terms from underneath the radical. And again, all of those are going to remove out, leaving us with, notice the 3 did not get removed. There was nothing to clean it out. So we're going to move the 5 to the front, again, under multiplication, times whatever's left over underneath the radical, which is 3. And then we're going to divide that by both the 4 and the t are coming out. And we're going to pause there to make sure that there's nothing left to do. The 3 definitely doesn't have any more perfect squared terms. 5 and 4 are not divisible, and there is no t's for it to be divisible. So that one would be done, or in the simplest form. Again, before, remember in the notes, we said that sometimes it's easier to simplify first. Looking at this example here, B, we notice that 3 and 21 are divisible, and also we can employ the exponent property of division, which is subtracting exponents. Again, this has an exponent of 1 that may be easier to deal with before we take the square root and separate them. So in this case, I'm going to go ahead and reduce that 3 and that 21. They're going to divide out, leaving a 7 in the denominator and a 1 in the numerator, correct? And I'm going to employ that, but I'll write that part down, the exponent property of division, where we're going to subtract. So in the numerator is going to be left that x cubed. And remember, we're taking the denominator and subtracting it from the numerator, so it should be 3 minus 1. If we move it to the denominator, then it would be 1 minus 3. But we don't want to do that. It's going to leave us with a negative exponent. There's the 7 that's left over, and now there won't be an x in there because it's been moved to the top, accounted for right here. So let's clean that up. We're going to be left with x squared in the numerator over 7. Now we're going to employ our division property with radicals, which says that I'm going to have a square root of the numerator and a square root of the denominator. Okay, this is going to nicely be in a form of an even number with our variable, and that means that those are going to reduce out, looking for squares to come outside of the radical. So the x comes outside, and that leaves the square root of 7 underneath. Now, standing here staring at this, this is done as far as we can take it. 7, it will not come out of the radical. It has no more perfect squared terms. There's nothing divisible. We're done. However, we're about to learn that we can't leave a radical in the denominator, and that's going to be for the next section of notes. So for now, this one's done. After the next section of notes, we'll need to take this a step farther. All right, thanks for watching. We'll see you in class.